And welcome back. We have been talking about vectors and how to load them and push things onto them and pop things off them. And in this example here, this is just not going to type a whole lot of code today, mainly because this is a lot of code to type, but also because most of this is pretty well understood and it's in the book. So we're going to talk about the bubble sort, the selection sort, and then people have been asking, how do I go about loading a vector? Well, loading vectors and loading arrays is really simple. You read from the file or the user input into some temporary variable or directly into it if you want for arrays, and you just keep stuffing it in. The difference is an array has a limited number. The size of the array is as many as you can do. So if you have a file and you're trying to take everything from a file and put it into an array, you have to know exactly the size of the file. If you don't know the size of the file, then the best thing to do is load a vector, because vectors will keep expanding as you keep pushing stuff on. So the way the load vector works reading from a file is like this. We've got a vector that comes in, and we're going to call, create a temporary variable, open up and create an indata IF stream, input file stream, and then open it to the file. This is called data.txt. We don't know what's inside here. I created a randomly generated file, and then I say, while I'm able to read an element, take that element that you just read in and push it onto your vector. So keep looping until you've read the whole file. Doesn't matter if there's 1 element, 10 elements, 100 elements, thousands of elements, it just doesn't matter. This is going to take care of that for us. And then when I'm done, close the data file. If you had an array, once again, you could pass an array without doing pass by reference, because this is what allows us to change it. If you take this one piece out, if you eliminate that, you'll make changes, but they won't persist. They won't survive the function call, because this will be a copy of an empty array for that matter. But if you have an array, an actual array and not a vector, what you have to do is say, okay, I need to pass in a size, and then make sure you loop, instead of a while loop, use a for loop to loop for a certain number of elements. This is very critical. Arrays, fixed size, vectors, who cares? Just keep stuffing it until you get it full. So that's the load function. And our main that sits up here says, okay, I've got a temporary number to play with for later. I create my vector, and then I load it. And now we get into chapter 8, which is how do I sort these things, sorting the vector. Well, the easiest sort they start off with is something called a bubble sort. The bubble sort says, starting with the very first element, compare it to the very next element, and if it's bigger, move it over one to the right. So you can kind of visualize this as moving from left to right, so that what you end up with after you make a pass through an array or a vector, that the element all the way at the largest index is going to be the biggest possible one you've got for a standard bubble sort. Then you go back and you do it again, and you find, hey, is the one that I sorted to the first position now bigger than the one that's to the right of it? If it is, you move it all the way down until it either finds its spot, or you find the biggest possible element in the 10 and you move it over. So this is just a sort of one element at a time, moving them all the way down to the end. The code looks just like this. You basically, in this case, because I have a vector, I don't need to pass a size, because I can find the size. Poof, ta-da, the size. So I can actually take the size, and using my for loops, loop all the way through. You need two for loops, one for every element and one for every element comparison, and you pass it through. So hey, is the first one bigger than the next one? If it is, swap them. If I swap something, I set this Boolean value to true, because basically what I'm going to try to do is optimize this. I don't want to have to keep going if I've already swapped everybody. So if I don't swap anybody, swap stays false. If I haven't swapped anybody, stop the loops. You're done. There's no point in continuing. So that's what this is called, an optimized bubble sort, by putting in this Boolean value. So we loop through it, push all the big ones to the right. By definition, all the little ones end up on the left. And when you bubble sort something, everybody ends up sorted correctly. Now, the nice thing about this is I can call bubble sort with my vector, passing it by reference. It'll come down here, do all of its happy little stuff, and when it's done, I now have a sorted vector. This is a very, very, very cool thing. Now you'll notice, or maybe you didn't, this thing right here, this standard swap. Standard swap is something that comes out of the algorithm library, which says, given two elements, swap them. Given two reference points, swap them. So, or two elements, period. This is a nice way of saying, hey, for this position, for that position, the next one over, swap them for us. I don't have to write the code for it. The code is actually in the book, and it's not that hard. You need a temporary variable, and you can sort it yourself. you can actually put that code right here, but I thought I'd show you something that's kind of cool, which is the algorithmic swap. And that will give us a bubble sorted vector, and then poof, we can now print the min and the max. Unlike having to do a linear search, which is where this chapter started off with, going element by element trying to find the min, which we did with arrays, I can just say once I've sorted it, hey, I can call the vector, and in the 0th, the first position, is the smallest number, and at the size minus 1, the very, very end of the array, the index that's there, there's the maximum value. So there's the min and the max. But to show you more cool stuff, using the vector methods, I can say, give me the front element or give me the back element, which is the same as these two here, just that they have built in a method inside the vector class itself to handle this stuff for us. And now we can sort and find stuff all over the place. Remember, there's a linear search, crank your way through it, and then there's something called the binary search. The binary search is also in the book. It's a way of splitting an array of values in half and saying, if it's already sorted and you're looking for some element x, if I find the middle element of an array or the middle element of a vector, I can ask, are you smaller or larger than the element that I'm looking for? If you're smaller, well then, and the element I'm looking for is smaller, that is bigger than that, then I know that on the right-hand side of the vector is where, or the right-hand side of the array is where I'm going to find it. So then I take the other half, split it in half, and repeat the process. So I'm constantly splitting an array of numbers in half, or a vector of numbers, or whatever I'm looking for in half that's already been sorted, and I can go find the element that I'm looking for. It's very, very fast. As a matter of fact, it's a binary thing by powers of 2, so it's log n type time to search. So if you find a power of n that multiplied by 2, and it's bigger than the whole size, then that'll tell you how many searches you have to do. In a linear search, you know that you've got to do at least half of the array on average if it's not sorted. Worst case scenario is you got to go through every element in the array. Binary search cuts that down to a fraction of it. So I think on an array of hundreds, it's like 6 or 7 searches. However, once again, just to show, binary search, you can write the code. I didn't bother to do it here. You can go find it. It's in the book. You can actually call the algorithm method that says, hey, do me a binary search. And then if I find it, if this comes back true, then I found the element. If it doesn't, then it comes back false. And we'll just run it. I've already run it a couple times, but we'll run it and show it to you. Boop. Poof. The min value is 10. The max value is 485. We found that because it was sorted inside that array. The min value is 10. The max value is sorted. So we can go find an array. Now the numbers I generated were less than 500. So if I put in, I don't know, I'll put in 100. We'll see if we can find that one. And it goes, poof, I found a 100. Yay. If I run it again, and I put a value in that I know doesn't exist because I stopped it before then, it'll tell me it's not found. So you can see that's the quick and dirty method of using a bubble sort. Do I want a selection sort? Sure, we can do it with selection sort. Selection sort says, go forth, go through the whole array, one element at a time, find the smallest one you can, and move it into the position where you're holding it. So you can kind of picture this as putting your finger over the first element and then asking, is there an element less than the one that I have my finger on somewhere over here to the right? If there is, then I swap them. And then I move over one, and I do the same exact thing again until I find it, and then I swap it. So you're constantly going through the array, just like a bubble sort. You constantly go through the array looking for smaller, moving the small one down to the left-hand side and going all the way to the top. You'll find that the selection sort method, ta-da, already here. The selection sort method does exactly that same thing. The only thing we didn't put in here is we didn't bother to optimize it because we really can't tell whether we're done until we finish going through the whole thing all the time. So compare. Are they the same? If they are, swap them. Or if you find the smallest one, swap it. So you look for indexes of where to find the minimum, the smallest value, as compared to where you are. So I'm looking for this one. I'm sitting at this one. So starting from where I am, go all the way through. If I find a small one, make the index equal to that, and then keep going all the way through until you find where to swap it to. And that's pretty much how a selection sort works. And if you wanted to see it work, we can run it again. And as you can see, the numbers all work out just the same. We don't get anything spurious or strange. Life is happy. And that's just a quick overview of how these things work, how selection sort, how bubble sort, and how to load something works. I wrote all the code here So you can pause the video and see what it is you need to see and copy out whatever code you want. You should go through the chapter, make sure you understand how this code is working. Make sure you can write it. Try to write it yourself and see if you can understand the concept. They give you pseudocode and real code. And with that, hope you're all having a great day.